So our second family is the Alkenes family, and we use that ENE in our name. So alkenes, very similar to what you wrote before, organic compounds that contain only carbon and hydrogen. Okay. And now there has to be at least one double bond. Okay. We're going to focus on one, and later in the course, we'll deal with what if there was two. But we just apply the same rules. Okay. 2-ene, it's a diene, and would need two numbers instead of one. Okay. Okay. Now we have an extra or a new definition coming in. Alkenes are said to be unsaturated. Okay. Okay. Saturated is when the bonding capacity of carbon is filled as much as possible with just C's and H's. Okay. Once you put a double bond in, you have to remove two H's to fit that double bond in, and that's where the definition of unsaturated is coming from. Does it have the most H's possible saturated? If there's a double or triple bond, it's unsaturated. This is the exact definition that's used with fats. If you've ever heard of polyunsaturated fats or monounsaturated fats, they're using that definition. A fat that is unsaturated has a double or triple bond. A saturated fat has no double or triple bonds in it. Okay. So you could go back and add into your notes the alkanes that we did earlier are saturated. They're filled with the maximum amount of hydrogen. Okay. And we're going to look at several ways we're going to name this one, and then we're going to draw it a few of the other different ways. Okay. This isn't a proper structural formula. I've condensed the H's in. Okay. Structural diagrams show every bond. This one I've hidden some. I've condensed it a bit. It doesn't look like there's any branches. If I start here, 1, 2, 3, 4, 5, 6, 7, 8. I didn't hit any branches going through my chain. 8 is oct. I see a double bond. That's an octene. And now I have to decide which end do I want to number from. I could either start this at this end or this end. Okay. Now it's very just short to get to it, so I'm not even going to count both ways. This end looks clearly to be the shorter one. Okay. If it's somewhere in the middle, you might actually count both ways and make sure you're right. Okay. We are counting bonds now, so this is our first carbon to carbon bond. Okay. There is an H to C bond here. Okay, but I don't count the H to C bonds. First carbon-carbon bond, that's the second carbon-carbon bond. Third, fourth, fifth, sixth, and seventh. There's always one less bond compared to the carbon count. So 8 carbons gives us 7 carbon-to-carbon bonds. So this is an oct-2-ene. Okay. So let's introduce some of the other ways to draw this. I'm going to do a line structure. Okay. You've never seen these before. Okay. These are the total opposite to our fully drawn out structural diagrams. Okay. There we're showing all the letters and all the bonds. In the line structures, we only show the bonds, okay? The carbon-carbon bonds. So in the line structure I'm about to draw, you're going to see all of these C's disappear, and you're just going to see single dash, double dash, single dash, single dash. That's all that's going to show up. You drop the C's and the H's when you do a line structure. Okay? So we've got 8 carbons. The end of every line is a carbon. Okay? And when 2 segments hit each other, there's a carbon at that intersection. It's the end of two lines, but where they overlap is just one carbon. So to draw these, I zig and zag to sort of follow Vesper, and when I drop my pen, I say 1 because that's the first carbon, and I just keep counting my carbons out as I zig and zag. So let's see this. I'll start on this side. 1, and I'm trying to get to oct. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to lift after I do 8. Okay? That has given me 8 ends of segments. There's an end there. 1, 2, 3, 4, 5, 6, 7, 8. Okay? The end of all of those are a carbon, but we don't draw it in the line structure. Okay? We don't draw the H's either. Okay? We will add O's and CL's and F's when we get to those, but C's and H's disappear, and we have to show the bonds. So this first bond is a single, but the second one is a double. So I have to double this one up. And that is the line structure for octene. Okay. They're simple to draw, but they're a little confusing till you get used to them. Okay. Now, you may not want to write this, but I'm going to write a strategy of how to decode these. What I suggest students do, if you're given this, if you circle all of the ends of all the line segments, it helps you count the carbons. Okay? So the green is not part of the answer. It's just a strategy for counting. I circled all the end of the segments, 1, 2, 3, 4, 5, 6, 7, 8. They really pop out. They're easy to count. Hopefully you don't make a mistake on a test or quiz. I'm going to take those out right now because they're not part of the proper drawing. Last, I want to do a fully condensed structure. I'm going to have to trying to leave this up here so you can see both. In the condensed structure, we're getting rid of all of the dashes now, and we're only going to keep the letters. So I'm going to do the carbon, what's around it, move to the next carbon, what's around it, and work my way across. Okay. So at this end, and in doing it, it doesn't matter whether I start at the end that we start numbering on. So I'm just going to mirror what's on top. Carbon with 3 H's. Okay. So I've condensed all the bonds away. This carbon, now there's a CH2 that's just hidden up above here. My board isn't tall enough. So the next carbon has 2 H's. I move here. There's a carbon with 2 H's. Here, there's 2 H's hidden up above. I move here. Move here. Here, I've got a carbon, but because of this double bond, there's only 1 H up there. And then I get here, carbon with 1 H.
Sorry for the interruption to grade 10 students. Last name, QRS. Please make your way to the gymnasium for your pictures. That's grade 10, QRS. Please make your way to the gym doors that are on the side in front of the woodshop. Okay. Thank you.
So it's easy to miss that double bond. You've really got to look for it. Now, you had questions like this last year in Chem 20, structures like this that you'd have to go and look for the missing H's. So the missing H here and here compared to the rest of the chain shows you that it's a double bond that's there. If you just had C with no H's and C with no H's, that's a triple bond that's been pulled out. Oh, I was worried about that as I was going up and down. I'm trusting you're right. I didn't double check the count. Okay, so we have a full structural diagram we saw earlier. This isn't full structural. Every one of these H's would have to be drawn out. Is full? Okay, this one's been condensed a little bit. That's condensed the most. And then this is the line structure. Those are the three formats you need to be familiar with: a structural, condensed, and line. Oh. Thank you. So that's the alkene family, not a lot else to say. So we've done alkanes, we've done alkenes, we're going to do alkynes, and then you're going to have some practice. And we've gone through a lot today. Again, these notes are very similar to the alkenes we just did. Okay, alkenes are organic compounds, contain carbon and hydrogen only. So the alkynes family. I'm underlining the YNE, it's going to show up in the name. There has to be at least one triple bond for it to be a member of this family. And just like the alkenes that had a double bond, the alkynes, if a triple, are also unsaturated. They are not filled with the maximum hydrogen that is possible. 2 pairs of hydrogen atoms have been removed to put in the double and then the triple. So in my alkyne example, there's no branches again. It's all one consecutive chain. 1 carbon, 2, 3, 4, 5, no branches. So 5 is pent. I noticed the triple bond, so it's going to be YNE. And then I need to figure out which end, either here or here, should I number from. If I start on this end, this is the first carbon-carbon bond. That's the second. So that'd be a 2, pen-2-ine. Over here, the first, the second, the third. So that would be longer. So this side gives me the shortest, the smallest number. So this is a pen-2-ine. Even if there was, like later, we might put a fluorine right here at the one, what would look like the 1 position, you would ignore it. Ignore alkyl groups, ignore everything, minimize to that triple bond. Stay numbering here. Okay. So we'll draw this, we'll do the line structure and then condensed, and then we're done for today. You'll have a little bit of practice time. So the condensed, you can still do my zig and zag. Don't worry about VSEPR so much. If you know VSEPR and you want to draw the proper bond angles, great, but you're not tested on it. That's why you see this piece straight. This carbon has 2 bonds. 2 bonds would give a 180 bond angle. But I'm going to ignore that, and I know I'm ignoring it, and please don't complain. 5. 1, 2, 3, 4, 5. Okay. This first bond is a single, and then the second one from the right is a triple. So I'm going to make sure there's 3 lines. Okay. Again, I know I don't have the right Vesper bond angles there, and you could manipulate it if you wanted to. And that's pent-to-ine line structure. Last, I'll do the condensed. I'll try to fit it up so we can, up high on the board so we can see all the structures. I'm going to start here and try not to mess up in my counting this time. The N carbon has 3 H's. This carbon has 2. My middle carbon has no H's. My fourth carbon has no H's. And my N carbon has 3. So that's a fully condensed structure. So you could easily see this on a test and be asked, what is the name of that? Okay, which gives you a couple options. Most students would probably draw it and then name it. If you were really strong, you would picture it in your head and then draw it. But I think most would probably draw that out. To be, particularly on a test, most are going to draw it just because you don't want to take the risk that you're picturing it wrong. So again, that's a line structure. That's the fully condensed. This one is condensed a little bit.